All right, so what we're going to talk about today is atherosclerosis, or the buildup of plaque within our vasculature. So the reason why we preface our discussions of acute coronary syndromes with atherosclerosis is it's our leading cause of decreased oxygenation to our heart tissue, and it's going to give us an idea of why someone may develop something like a stable angina or unstable angina versus a myocardial infarction. Atherosclerosis is an important factor that we're going to talk about continuously throughout the semester, as it's going to be a risk factor for a number of the pathologies we talk about, and it's also going to be caused or be a consequence of a number of the pathologies that we talk about. So when we're talking about atherosclerosis, we're really talking about three things. We're talking about someone having a buildup of LDL or of cholesterol within their tunica intima. We're talking about someone who's going to have an inflammatory response within the tunica intima of their vessel. And we're going to talk about someone who eventually is going to have some sort of necrosis, which is really going to help with plaque formation within their arteries. So if we take a look at the levels of the cell or levels of the vasculature that we're talking about, atherosclerosis is really going to target the tunica intima, or it's going to target the space between the vascular endothelium and the smooth muscle cells. We're looking at the tunica intima here. If we're looking at the smooth muscle layer, that's our tunica media, or that's the level of the vessel that's responsible for vasoconstriction, and this outer layer is the tunica adventitia, or externa, and we'll just call it externa here. So those are our three levels of vasculature. So like we said, what's happening in atherosclerosis is we're generally having some sort of buildup of lipids within the tunica intima, and that can happen due to a number of reasons. So if we look at the risk factors that are going to lead to someone developing atherosclerosis, obviously having high cholesterol is one of them. So someone with high cholesterol is going to have an increase in infiltration of LDL into their tunica intima. And the leading cause of atherosclerosis is high cholesterol, or people who have a unnaturally high level of LDL circulating through their blood. So someone who has a high level of cholesterol is going to put them at risk for developing atherosclerosis, because this cholesterol, or these LDL molecules, can make their way into the tunica intima and kind of start some of the processes that are involved in atherosclerosis. If we look at risk factors, one of the things is having high cholesterol, or having high levels of LDL circulating through the blood. Now, another thing, or another risk factor that can lead to someone having an increased risk of developing atherosclerosis is hypertension. So people who have hypertension are at increased risk of having atherosclerosis due to some other means. So people with high blood pressure generally have a high amount of circulating vasoconstrictive hormones. And the more vasoconstrictive hormones we have circulating through the blood, it's going to lead to a couple of things. It's going to lead to more turbulent blood flow, and it's going to lead to stimulation of the vascular cell or vascular endothelium, which can lead to atherosclerosis, and we're going to kind of explain that in a second here. So people with increased blood pressure have increased circulation in vasoconstrictive hormones. We'll just label that VC for now. So increase in vasoconstrictive hormones. And we can put those in green here. So people with high blood pressure have a high circulation of vasoconstrictive hormones, which can do some sort of cell signaling on the endothelial lining. Other people who are at risk of developing atherosclerosis are diabetics, or people with diabetes mellitus. The reason why diabetes is going to increase your risk for atherosclerosis is we have an increase in the release of byproducts from glycosylation, or glycoxidation, sorry. So glycoxidation is basically an oxidative process that involves glucose, and what's going to happen is we have some sort of byproducts related to that. So we have byproducts of glycosylation. Glycoxidation. And these byproducts circulating through the blood can also stimulate our endothelial lining. And finally, one of the other main risk factors that's going to lead to atherosclerosis is people who are obese. So obesity is also going to play a large role. And the reason for that is people who are obese have increased circulation of inflammatory cytokines. And those could be circulating through our blood. And usually, in most people, and I'm sure those that we've seen on the road, have the same issues. So they have probably a combination of high cholesterol, high blood pressure, obesity, and potentially diabetes also playing a role. So just to recap what we're talking about here, is someone can develop diabetes mellitus or can develop atherosclerosis in a number of ways. So one of the things that can happen is someone can simply have high cholesterol. And what's going to happen is those cholesterol molecules can make their way into the tunica intima, where they can start to build up and they can start a cell signaling process. Now, someone doesn't necessarily need to have high cholesterol in order to have atherosclerosis. So what can happen is I could have high blood pressure, diabetes, and obesity, and even though I maybe have a normal level or I've got my cholesterol levels under control, I can still develop atherosclerosis because they're going to lead to a cell signaling process that's going to cause increased storage of cholesterol. So even though I might not have higher levels of cholesterol, I can still store more cholesterol in my tunica intima because of the signaling process that these factors can result in. So whether I have increased LDL or whether I have high blood pressure, diabetes mellitus, or obesity that's leading to this circulation of hormones or byproducts that's causing endothelial signaling, what happens is I put basically adhesion molecules on my vascular endothelium. So what happens is if I have high levels of cholesterol or increased vasoconstrictive hormones, byproducts of glycoxidation, or inflammatory cytokines, I put molecules on my cell surface that are going to increase the adhesion of monocytes. So, because of high levels of cholesterol or increase in blood pressure, diabetes, or obesity, I'm increasing the presence of adhesion molecules on my vascular endothelium. What happens with these adhesion molecules is they stimulate monocytes to come to my cell surface and bind. So what happens is that I have increased binding of monocytes. So what we're seeing here is a monocyte. Binding to our vascular endothelium. Now this monocyte is going to do a couple of things. One of the roles of this monocyte is to start an intracellular signaling cascade or send signals to the inside of the cell, which is going to lead to a migration of our smooth muscle cells to our tunica intima. So one of the things we see happen is our smooth muscle starts to migrate down into our tunica intima. So we start to see smooth muscle cells forming in our tunica intima. Another thing that we're going to see happen is increased expression of inflammatory mediators. So as this monocyte binds, we're going to increase the amount of inflammation that's happening. So we have an increase in inflammation. So smooth muscle cells are going to come down. We're going to have an increase in inflammation in our tunica intima. And the last thing that's going to happen is those monocytes can actually make their way into our cells. So those monocytes can make their way into the tunica intima. And what happens is we see a monocyte making its way into the tunica intima and actually eating up some of this LDL that we have. So our monocyte makes its way into the tunica intima, eats up this LDL, and it becomes what they call a fat-laden foam cell. So if we kind of recap what's happening is we have three things happening. Because of our risk factors, because of the things that are leading to our increase in atherosclerosis, we're having increase in monocyte binding, which leads to inflammation. We are having smooth muscle migration as a result of monocyte binding. So we have smooth muscle migration. And the third thing we're having is formation of fat-laden foam cells. So we have inflammation, smooth muscle migration, and the formation of fat-laden foam cells. So what happens in this case is we start to have the buildup of smooth muscle cells, these big fat foam cells. I'm going to fill those in with green so they're obvious of where they are. So we have this fat-laden foam cell living within our tunica intima. We have our smooth muscle cells, and we have this inflammatory process that's going on. One of the things that's important to note is the problem with these three things happening at once is they kind of make our extracellular matrix of the tunica intima sticky, or it wants to bind more cholesterol. So as these three things happen, it actually promotes further binding of cholesterol. So these three things promote further LDL binding. And as a result, we get more LDL building up in our tunica intima, which again is going to lead to this whole process starting over again. So if we look at this kind of process, it's quite cyclic. So as we promote further LDL binding, then we go straight back to the start where we had increase in LDL, which is going to lead to an increase in adhesion molecules, which is going to lead to this whole process that we just talked about. So it becomes a very cyclic process as we begin to store LDL into our tunica intima. So if we recap what's going on, or we take a look at kind of a flow chart of what's going on, we have someone who maybe has high cholesterol, or again, we can talk about this in the terms of high cholesterol, high blood pressure, diabetes, or obesity. What happens is we have an increased amount of lipids maybe within the tunica intima. But the main thing that we're seeing is we have an increase in adhesion molecules to the vascular endothelium, what we're seeing in this stage here. So when we have this high cholesterol or these risk factors, we have an increase in adhesion molecules, which are allowing monocytes to bind to the vascular endothelium. What happens next is we start to see monocytes entering into the artery, and we have some of this macrophage conversion. So as monocytes make their way into the artery, we start to see smooth muscle cell migration, or the smooth muscle cells migrate into the tunica intima. We start to see a pro-inflammatory response, or we start to see lots of inflammation occurring. And finally, we start to see our macrophages eat our lipids and become fat-laden foam cells. So our macrophages actually eat our lipids, become fat-laden foam cells, and basically house themselves in this tunica intima. Like we talked about before, this also stimulates further LDL binding. So it stimulates more cholesterol to make its way into this area that we now have inflammation, smooth muscle cell migration, and the presence of these fat-laden foam cells. And it's going to cause this process to be cyclic and to occur again until we start building up a large plaque. And as we go from there, we start to see some cell death, some necrosis, and we start to have the formation of a plaque. So if we take a look at what that looks like without looking at the cellular processes, we can see what's going to happen to our vasculature. So if we take a look at our artery again, and now draw in what's happened when we have someone who has high cholesterol or high blood pressure, diabetes, obesity, and has started to form a plaque. So we know that this person has some inflammation going on. So we have some inflammation in the tunica intima. We know this person is going to have a high population now of these fat-laden foam cells. So these guys are now living in this tunica intima. And we filled those with green and yellow before. So these are our fat-laden foam cells, or our macrophages that have eaten our LDL molecules and made their way into this tunica intima to be their new home. So these are our macrophages, or foam cells, that have eaten all these lipids and stationed themselves in the tunica intima. So these are foam cells. And lastly, we know that we have this migration of smooth muscle cells. So we have a high amount of smooth muscle cells migrating their way into the tunica intima. So we think about what this is going to do. If I've lost smooth muscle cells from my tunica media, it's going to be stretchier. I'm only going to have a few smooth muscle cells living on the outside. I'm not going to have that durability I had before. My tunica adventia, my tunica externa, is easily moved at this point, or can be easily moved around. And what happens is I start to see it moving outwards. So as this plaque continues to build up, and remember, these are becoming quite stiff and hard as necrosis and apoptosis occurs. What happens is my tunica adventitia, or my tunica externa, moves out, my tunica media moves out, and I start to have the formation of a plaque. Now, as this process progresses, usually we see more outward movement. This is why people can live with atherosclerosis for a long period of time without having symptoms. This is a great example of how people can live with atherosclerosis in their coronary arteries, never have an episode of angina, and suddenly have a heart attack. And that's because we don't see this impediment into the vascular lumen. Because remember, this is where our blood is flowing. It's through our lumen here. Well, we're not seeing that lumen being affected. All of our movement is outwards at this point in time, where we're seeing all this movement moving out towards the tunica externa. And that's the way it's going to occur for a large majority of time. Now, what happens as this process continues to occur, and we have a kind of continuation of this buildup of foam cells, inflammation, and as we talked about before, more lipids making their way into our tunica intima as these guys become sticky and want more things to be pulled into it, is eventually this plaque is going to start to encroach onto our tunica or endothelial lining, or it's going to encroach into our lumen. So eventually what's going to happen is, as this all builds up, our lumen is going to get pushed in. So our lumen gets pushed in. We see our tunica tissue moving out through all of this. And as we have a large amount of plaque forming, that's when this starts to encroach into our lumen. So again, we have our fat-laden foam cells. We're going to have our inflammation and our inflammatory processes building up in this space. We're going to have our smooth muscle migration. And eventually, as the plaque becomes bigger, it's going to make its way into our lumen, and we're going to have a decrease in lumen size. And this is where we can start to see some of the problems related to atherosclerosis, because now we have a reduction in blood flow, or we have a decrease in blood flow through our lumen. As mentioned before, we're also going to have more turbulent blood flow through our lumen, and we're going to lose our laminar flow of blood through the lumen, which can have some problems. It's going to perpetuate things like high blood pressure, and it's actually going to make atherosclerosis even worse. Now, important thing to note is as we push out this endothelium, we're stretching it and we're causing damage to it. So because damage to this endothelium, we stretch it out, and we're going to cause some inflammation to occur to that endothelial lining, and some repair. So we have some necrosis and repair to this endothelium lining, and we're going to form what's called a thin fibrous cap. So now what we have forming where our endothelium is a thin fibrous cap. So we call this our thin fibrous cap. And the importance of the thin fibrous cap is that it can rupture. So when that thin fibrous cap ruptures, that's when we have a problem, or that's when we start to see things like platelet aggregation and clot formation happening. When we start talking about atherosclerosis, when we start talking about things like acute coronary syndromes, we'll start getting into the details of what's going to happen when a plaque ruptures.